You're 7 years old. You attend the second grade in your local American city, and there's a 13% chance that you live in a food insecure household. That means that you rely on your public school system to provide you with breakfast and lunch, and when you get home, you may do what you can. In 2015, there were 42 million Americans living in food insecure households. That's 29 million adults and 13 million children. Speaking in global terms, we have a population of 7.3 billion. 1 in 9 of those people suffer from hunger-related issues. These numbers are way too large, and that's why I'm here today. My name is Youwakim, and I conduct research in sustainable agriculture. Okay, I grew up in Southeast Texas, very close to the Louisiana border. Back home, seafood is a food group, and it's highly praised to fry the unfryable. Needless to say, food has always been a big part of my life. And hunger is something that I've always been passionate about because it's something I never understood the reason for. In the US alone, we waste 40% of the food that we produce, and that means it never makes it to your table. So, upon my high school graduation, I graduated from my small town, and with minimal college preparatory resources, coming to a large university such as UT was a big adjustment for me. However, I excelled in my freshman year calculus course, and Professor Walashensky was full of stories and empathy for his students, so that was something that really encouraged me. After my freshman year, I went home for the summer and was thinking about how I really wanted to direct my degree in economics to studies that I was passionate about. So I decided to combine my two interests, math and the environment. So I emailed Bill, and Professor Walashensky always told his students to call him Bill. So I sent Bill an email and told him about my interests and asked if he knew of any mathematics professors who were doing environmental research. And coincidentally enough, I learned that Bill used to be a corn farmer in Nebraska. And he loved doing research with me. So here begins my journey with a grain that I had previously never heard of. Sorghum. Sorghum is a grain that is identical in use to corn and is both nutritionally and environmentally superior. So in the United States, fields for agriculture are separated, and we reserve 30% of fields to corn. This is because of a lot of reasons, but mainly corn is used in a lot of products that you wouldn't think it's in. It's in jam and yogurt, and it's even in your toothpaste. So, what does this mean for us? You know, like, why is corn so bad anyway? Corn uses a lot of water, and that's water that we don't see being readily available in terms of climate change. So climate change research shows us that we'll receive the same amount of precipitation, but it's going to come much more infrequently. And corn is a crop that needs regular irrigation. So here began my research. So my research was to take corn and sorghum and grow them next to each other in a climate change irrigation model. So on April 19th, Professor Walashensky and I planted 2 rows of yellow dent corn and Mennonite sorghum. And the first row was to receive 1 inch of water a week, and the second row was to receive 2 inches of water every 2 weeks to stimulate climate change. So for the first 6 weeks, the seeds simply germinated and took water from the soil. And after that, on May 21st, we snaked a drip liner between the rows, and as you can see there. And then we covered them with a tarp. This was to prevent any external rainfall from hitting our plants. So as the summer went on, I checked on my plants and continued with our irrigation model. They grew taller. That's sorghum on the left. And as the summer went on, they got browner and they were ready for harvest. So on July 30th, we harvested our crops. And as you can see on the left here, this was the corn that received water every week, so it's very full and healthy. And this was the corn that only received water every 2 weeks, so it's significantly produced less. And once you shell them, you can see, that's my hand there, you can see the stalks. The cobs didn't receive, they didn't grow as full because the one on the right only received water every 2 weeks. So after that, we weighed them, and we saw a 27% yield decrease in the corn, but only a 13% yield decrease in the sorghum. A decrease was to be expected anyway because we were watering infrequently. And those are some sorghum grains. So My conclusion there is that one small way to solve our food insecurity crisis is to slowly phase out corn and put sorghum in its place. So there's a graph showing how our corn grew. It was very healthy, grew to a normal height. And there's a visual for the differences in yield loss. In this research, I encountered some challenges and some rewards as well. Particularly in agricultural research, soil and frequencies are something that you can't control, as well as storms. So I've learned a lot of patience there. And also, I want to say it took me about 5 or 6 tries to plan out a good climate change model and write proposals, and it means something, I think, when somebody decides to fund you, when you receive a research grant, it is really meaningful to me because someone has decided that your work is valuable. So there were lots of challenges and rewards in this project, and hunger affects everybody. It's a domestic and international issue that's easily solvable, and everybody eats. So this research is really important to me, and it's my passion to find crops that can sustain the effects that climate change will have, but also have minimal yield loss. So thank you so much.